The most important feature of amateur radio is to receive signals as clearly as possible. Unfortunately, we're surrounded by all sorts of noise. This video deals with many noise sources that affect amateur bands and describes some strategies for tracking them down. We may not know where the interference is coming from, but one thing is for sure, you'll receive very little assistance from electrical suppliers or telecommunications regulators unless you can first provide a lot of information about the problem. Getting a formal investigation underway is expensive for them, and from their perspective, they don't want to waste resources chasing ghosts. You're going to have to prepare a strong case that says where they should be looking before they'll react on your behalf. That's what this video is for. It's difficult to elaborate on all of these factors in this video, but we'll cover as much as we can. Here we'll be focusing on interference affecting home stations. For more information about dealing with interference, visit the website QRM Guru, where these topics are dealt with comprehensively. So, if you turn on your radio and experience some interference, certainly take some action, but do it the right way. We've broken down this task into two distinct phases: gathering information and tracking down the source. While gathering this information, make some notes. We'll need to look at three distinct patterns in what we experience: a sound pattern, a frequency pattern, and a timing pattern. If we are ever called upon to present formal evidence, then the notes we take here will become very important. Sound patterns. Listen carefully. If possible, make your own recording of what you are hearing. Is it a non-repetitive buzzing noise? Continuous wideband noise is typical of interference from a domestic appliance or a lighting system. Is it a blend of modulated signals from some commercial transmission? A combination of voice, data, or other deliberate modulation could mean that you're experiencing a mixing event that places the sum or difference frequency of two stations exactly where you happen to be operating. Is it a systematic crackle or rattle? Signs of crackles and rattles that interrupt the interference at irregular intervals could indicate a form of external mixing and retransmission. Two metallic surfaces rubbing together that have no physical connection to a nearby transmission can still create havoc, particularly on windy days. Next, we look for frequency patterns. Is it a fixed frequency? Use a general coverage receiver and try to see if the interference only appears in one place. Very stable interference is a clue that there are probably commercial transmitters involved. Does it slowly wander across a range of frequencies? This can be a sign of parasitic oscillation in a transmitter's output stage as it warms up. Is it a continuous wideband noise? This is a classic sign of switched mode power supply noise from LED lighting and home appliances. Does it appear on multiple spots up and down the band? Some cable TV services produce this effect. Take a note of where the interference is at its strongest and how far up the spectrum the interference reaches. We'll use this information when we begin tracking the signals. Maybe this is difficult to do without access to special equipment, but take it as far as you can. Go back to your rig and work your way up the spectrum and try to find the highest frequency where this interference can be heard. Take notes. Don't be afraid to look at VHF and UHF parts of the spectrum as well. Switch to a different antenna, perhaps a section of wire inside your room. It's good if you can get access to a general coverage handheld with an AM receive mode, as interference tends to be amplitude modulated. Lastly, we look at the importance of timing patterns. Is the interference there all of the time? If it comes and goes, what's the interval? Does the interference reoccur at similar times each day? Does it follow a pattern of daylight and darkness? One of the strongest clues in identifying our interference source is to log when the interference comes and goes. Wideband noise that only appears at night could be from a neighbour turning on an outside floodlight, but interference that peaks in the middle of the day could be coming from a solar inverter system that's generating maximum power. Does it get worse in windy conditions? Does it get worse with rainfall? Does it improve after rain has fallen? Is there no discernible pattern? Interference associated with long dry spells and rain are common symptoms of power line noise. Dust on insulators can slowly build up over time and begin to arc out and generate noise. This noise may then stop after a good storm flushes away the dust. Pole transformers may begin to break down internally under heavy loads and hot days, which often occur at the same time. Once we've recorded as many details as possible, we can move on to the second phase where we try to physically locate the source of the interference. Various techniques for doing this are discussed in our next video in this series.